So hi everybody and welcome back to this C++ tutorial series for absolute beginners. This is video 276 and in this video we continue with our exercises, and like all time, here is the question. You pause the video, try to answer the question as good as you can, and then you start the video again and compare it with my answer, and later we watch this in the oral documentation if this is really so what I talk to you or present it to you. All right, let's get started. Here we are on number 18, and number 18 says, what is wrong with my virtual function example? Actually, this is the virtual function example from here, and here is something wrong which I showed you not, and still wrong here, but your job is now try to figure out it in this little code here. I uncomment this one fast. And here is something wrong, and these are just wrong because I have here no comments. That's not the wrong mistake. So we have here a base class, and then we have here a derived class, and here is something wrong, and you should try to find it. And of course I pause not the video and I present you now the solution. And the solution is, we jump here. First of all, there is a missing delayed, and there is no virtual destructors. So there is not only one thing wrong, there is actually two things wrong. So, and let's see what I mean with the missing delayed. First of all, when you see here is a int main, and this int main is using the keyword new, and we learned if you see new, you should use delayed anywhere when it goes out of scope, and here it goes definitely out of scope, which means we cause a big problem. We have memory not freed and it is occupied. That's why first of all we need delayed, and then of course this one here which we just created, I copy this one here and then paste it here, and this. But this is the first mistake. There are more. When we use delayed, what happens then? The next thing is this delayed will call a destructor, and we have not provided a destructor, which means this one will use the default destructor normally, but we have here a base class and an inherited class, and this one here is a pointer to the base class from here to here, which means if I'm going to delete this one here without a virtual destructor, it will just delete this one here on top, but not this one here, which means the memory here is not freed, whatever you have implemented in this part here. So we have a big problem again, which means we have just to add a virtual destructor. You write here virtual, and then make this tilde symbol. Let's see if I can make this with my keyboard. Yeah, this one. And then fun. And you don't have to do this one. Let's put it on top. And again, you don't have to write in this thing anything else, but you can do it. So then I think for destructor we don't even need that one. And here is still one mistake. You have here a virtual destructor. You need this one here as well. So here we need a destructor as well. And here again, something important. This destructor can be declared with without virtual, but it is still virtual. We don't see it. All right, that's also important. So you can make it like so and say, okay, I have here a destructor now. If you want, you can write it here or not. So that was our mistakes. Actually, there could be much more mistakes, but these are the main mistakes which you should avoid. So, and I think we can go to the next question. But before we go to the next question, let's jump here. Here is the virtual destructor section, by the way. And you can see you should read this again. We are still on the page with where we are on here on virtual function specifier, and when you scroll down there is this where is the section? Not this, where is this virtual destructor? Is that down? On the almost down. here is virtual destructor, and then you can see you need a virtual destructor. This one is also virtual, it only looks not so like, but here they are explaining it here a little bit more in detail, and they are explaining here also what happens if you not provide this one here, that this one is also a problem. And there is this one guideline, which is this this guideline. I think I showed you this one. This is the one article which one person wrote. Is this article, or is this for something else? I think it's the article one. You can read this one. I don't know if this is one. Anyway, you read this. It says in short term, you make it public with virtual. For example, if this is public, then you use a virtual, or you make protected and then you don't need virtual. But careful, protected means also you are never creating this one here. You are never creating a pointer to the base and then with the word new. And that's the problem with this, because you don't know the future. How the hell you know that you will never use it? And that's why I say, for starters, it is safe. When you see a virtual, just make a virtual destructor. Doesn't matter if you need it or not need it, because you don't know the future, and this is all time safe. The other one is also safe, because if you make protected, you can't create this one, but you are limiting yourself, the class, just to never create this on the heap. This word new will create this object on the heap. And most time classes are not small. Here in our demonstration, when we learn classes, and you can see this demonstration classes, they are small, but most time you don't know how big the class can be. And if it's big, then you put it rather to the heap instead of the stack. And that's why this one is a good option to use all time, a virtual destructor in general. So what I would prefer. And then let's go to the next question. The next question says here, let's uncomment this fast. And you can read here already. Oops, I have to show you the agian code, so you can't. So let's give me a second. And then the next question says here, what is here wrong, and explain it why it is wrong. So again, we have here again a code. It's a little bit longer. Let's see if I can fit this here, uncomment in one place. Let's see. Oh, it is this one. You can ignore. Okay. This one is not the real. Yeah. So, okay, that was not good. It's already showing one mistake. No, but okay, you have here this class. Try to, let's see if I can make this a little bit bigger and then scroll it down so that you can examine it a little bit better. So, here is nothing. So this is almost the full thing what I have here. Let's make this one higher. So, here, that is all. And now you should try to understand what happens here and then try to find the mistake. Okay, the mistake is obviously this one, but try to figure out what is the mistake. Actually, there is one. There are several mistakes in, but this is the main mistakes, and you have to try to understand it. So I hope you pause the video, you analyze this code, and found the mistake. So let's start. Before we go here to this mistake, let's start here. We have here already a mistake. Again, we have here virtual, and they are public, so we need virtual destructors, what we just learned here before. But here we have other problems as well. This is a demonstration code, but still when you use it, this one has not even a definition. This is just a declaration. That's why I have this green scribbles below. Then what we have here is, now this should be a little bit the point. What should you think a little bit more? Look this one here and look this one here. What happens here? I hope you remember this one. That is a little bit tricky, because normally when we declare a virtual function, the return type should be the same, but we know there is an exception with virtual function, which is the covariant, which means I can have a different return type. And that's why this one here is not an arrow. That's very important. This is not an arrow, and it must satisfy the covariant constraints, but if it's so, that will work. So this is not the arrow. And then let's go here again there are virtual destructors missing and so on, but okay. Then we create here some objects, and then we call this one here. This is just a normal virtual function call. This one here, I hope you remember this. Here it's important. So this is this VF4 here. Yes. So here it works. That is not an arrow because this one is a let's see, this is not even a covariant. This is a covariant, yes. And here it works not. And the reason we had explained why it works here not and why it works here. That was the one thing what you should also try to see. And the thing is, covariant need all time a pointer or a reference. Here we don't have a pointer. When I hover my mouse over it, and it says here, yeah, it says here not constructor, but the real reason is it's not a pointer, because that would be a covariant here. Then it would work. All right, I hope you saw that. And actually this example here, I just copied from here, what we already talked in one of our videos. Where is the covariant now? Here, the covariant return times. I copied just this one here, so you can see this is almost the same. I just throw out some other things. So you can see this one are normal virtual function call. This one are with pointers, and important is the covariant conditions are here on top. You can read this, and one of them is it must be a pointer reference. You can see that's why this one worked not. It was not a pointer. And let's see what we have here more in covariant. Yeah, and then here how this is overwritten. And then I have not showed you this, how it can hide. For example, this one, if you just declare a virtual function has a other signature, which means another parameter here, and the other one has not, then this one is taken, the other one will not use, and it is not a virtual function call. It says here also. And yeah, this one is our covariant type because it works. That what is strange. Many say that's not working, but careful, we have here the type, here are the type, and still this is our virtual function call. So you can call this one, it will go here, and yeah, that's kind of a little bit tricky to see at start as a starter. It's generally tricky even for advanced people to see it instantly, and only when you train this a little bit. And then we have here a little bit more. You can see this one is not working because incomplete type again. A is just a forward declaration here. And let's see what they have here more. You can see, and here a little bit more reading how this works. We have talked this, but I hope you realize this while you watch that. That was that for this part actually. And with that said, I stop here this exercise. If you have any questions like all time, write it in the comment section. See you in the next video. Bye, good luck, and like all time, have fun and never give up.